Section 2.1 to 2.5, review for the exam. Calculators are still not allowed, and this is number 4. So number 4, we're looking for limits as long as a is a positive number. If I look at part A, my first line of defense when computing limits that are not piecewise functions, in other words, I'm not looking at a joint, is I plug it in and see what happens. If I plug in a on top, I'm going to get a cubed minus a cubed, which is 0. If I plug in a on the bottom, I get a minus a, which is 0. So this is a 0 over 0, which is usually evidence of a whole. If it's a whole, I should be able to fix it. By fixing it, that means I'm going to factor. I have a difference of 2 cubes here, and I gave you a difference of 2 cubes on your review because you can probably cheat a little and figure out how to factor that difference of cubes. But on the test, I will give you factors that you know how to do, like differences of squares or easy factors that are just foiling backwards. So here, just to practice and kind of refresh your memory on that difference of cubes, I'm giving it to you. So now that we have factored, we can see that a minus x shows up in both places. So I can reduce that out as long as x doesn't equal a. And remember, limits don't deal with what happens at that value, it's just when you're near it. So now I'm able to just plug a in because it's no longer a problem. I'm no longer dividing by 0. So that'll give me an a squared plus an a squared plus another a squared. So I end up with 3 a squareds. Kappa, you're way too noisy. Next one, part B. Part B, I again am looking at the limit as x approaches a, and we can see here that I have an a minus an a. When I plug that in, gives me a 0 on the bottom, but the top is still going to be a, which is a number that is bigger than 0. So because I have a number divided by a 0, that's going to give me an asymptote. Because it is an asymptote, that means I need to examine what's happening on both sides. So I will look at the limit as x approaches a from the right, and I will look at the limit as x approaches a from the left. Remember, since it's an asymptote, that I'm really only interested in the sign of the output, because I already know it's either going to be positive infinity or negative infinity, because I've identified that it's an asymptote. So if we look on the right-hand side, that means I'm plugging in a number a little bit bigger than a. Something bigger than a minus a will give me a positive number, and when I square it, it's still positive. And notice that the top is a positive number as well. So we'll end up with a positive infinity. If I plug in a number smaller than a and then subtract a, this inner piece right here will be negative. But when you square it, it becomes positive. So again, I have a positive over a positive, which is a positive. Because these two match, that means both my thumbs are moving up as I approach that asymptote, and my two-sided limit will be positive infinity. Okay, third one. Again, I'm going to write it off the screen and then I'll scoot. I'm looking at the limit as x approaches a of a divided by x minus a. If I plug a in, I get 0 on the bottom, and I don't have a 0 on the top. So again, I have a number over 0, which is evidence of an asymptote. Because it's an asymptote, I need to look at both left and right sides to see if I am behaving the same way on both sides. So if I look at it coming from the right, I already know it's either going to be positive infinity or negative infinity, so I'm really just interested in the sign. Something bigger than a, plugged in here, subtract a, that's going to give me a positive number. And we already know a is positive on top, so the overall result is positive. On the other hand, if I look at approaching that asymptote from the left, now I'm looking at numbers a little bit smaller than a. So a number smaller than a minus a is going to give me a negative on the bottom, and I still have a positive on the top. So the overall result ends up being negative infinity. These two do not match. My thumbs are fighting each other as I'm traveling along the sides of that asymptote. So that means my two-sided limit as x approaches a of a over x minus a does not exist.